During an adiabatic process, the pressure of a gas is found to be proportional to the cube of its temperature. What is the value of the ratio of Cp by Cv for the gas? The question involves an adiabatic process where the pressure P of a gas is proportional to the cube of its temperature T, which means P is proportional to T cube. We need to determine the ratio Cp by Cv for the gas. For an adiabatic process, the relation between pressure and temperature is derived from the ideal gas law and the adiabatic equation given by Pt to the power gamma by gamma minus 1 is equal to constant. And rearranging this, we get P is proportional to T to the power gamma by gamma minus 1, where gamma is nothing but Cp by Cv and it is a ratio of specific heats. The problem states P is proportional to T cube. Comparing this with the expression P is proportional to T to the power gamma by gamma minus 1 and equating the exponents, we get gamma by gamma minus 1 is equal to 3. Solving for gamma, we have gamma by gamma minus 1 is equal to 3. Let us multiply throughout by gamma minus 1. So we get gamma is equal to 3 into gamma minus 1. Let us expand and simplify this. We get gamma is equal to 3 gamma minus 3. Rearranging the terms, we get 2 gamma is equal to 3, which means gamma is equal to 3 by 2. So the correct answer is option C, 3 by 2.